What if we could power our world without leaving a mark on its surface? Imagine a mine with no giant pits, no mountains of waste rock poisoning the earth. For centuries, mining has meant tearing into the planet for its treasures, fueling civilization, but always at a cost. But what if there was another way? A gentler, quieter method to get what we need from the ground. This isn't just a dream. Scientists and engineers are rewriting the rules of mining right now. In the vast landscapes of northern China, a quiet revolution is taking place, mostly underground, hidden from sight. It promises to provide a crucial element for clean energy, uranium, without the destruction we've come to expect. This new approach could change everything we know about resource extraction. The world needs more energy, and as we move away from fossil fuels, nuclear power is key. But nuclear power needs uranium, and traditionally, getting it has been messy and destructive. The story unfolding in Inner Mongolia offers a way out of this dilemma. It's a story of innovation, scientific brilliance, and respect for the world beneath our feet. We'll travel to the remote deserts of Inner Mongolia, going deep underground, not with shovels, but with clever chemistry and precision engineering. This is the story of how we might get the power we need while protecting the planet we love. Can we truly mine without leaving a scar? The answer might surprise you. Our journey takes us to Inner Mongolia, a land of epic scale and stark beauty, where the Gobi Desert stretches endlessly. On the surface, it seems empty, but beneath lies a secret vital for the 21st century. Geologists suspected something valuable was hidden here: sandstone deposits laid down by ancient rivers. These porous layers, trapped between impermeable clay, were perfect for minerals to accumulate. The mineral they were hunting for: uranium. Unlike solid veins, this uranium clung to grains of sand in a waterlogged underground layer, like a sponge soaked in minerals. Traditional mining would be impossible here. Digging a giant pit would devastate the fragile desert. The treasure was locked away in a form that defied old methods. Scientists realized they didn't need to dig up the rock. They just needed to wash the uranium off the sand grains deep underground. This insight turned a geological problem into an incredible opportunity. The Gobi's hidden treasure wasn't just uranium, it was the unique way it was stored. This allowed for a revolutionary new kind of mining, one that could leave the landscape almost untouched. The challenge sparked innovation, and a new chapter in mining began. The desert's secret was out, and it would change everything. A new era of resource extraction was about to begin. How do you get uranium out of the ground without digging a giant hole? The answer: in situ leaching, or ISL. Think of it like making tea, pouring water over leaves to dissolve flavor, but on a massive scale, deep underground. Engineers drill a grid of small wells into the uranium-rich sandstone. Some wells inject a harmless solution, water mixed with oxygen and baking soda, while others pump it out. The solution seeps through the sandstone, dissolving uranium from the sand grains, just like water dissolves sugar in tea. The uranium-rich liquid is then pumped back to the surface. At the processing plant, uranium is separated and the water is cleaned and reused in a closed loop. On the surface, all you see is a network of pipes and a few small wellheads. No giant pits, no mountains of waste. The mining happens silently, deep beneath the desert. This method is subtle, efficient, and leaves the landscape almost untouched. It's a continuous underground tea party, extracting uranium with minimal disruption. The process is slow and controlled, ensuring safety and precision. The beauty of ISL is in its simplicity and respect for the environment. It's a revolution in mining, quiet, clean, and effective. The desert remains undisturbed, while the world above continues as before. The difference between this new method and traditional mining is dramatic. Old-school uranium mining meant open pits, explosives, and massive scars on the earth. It destroyed habitats, displaced wildlife, and left toxic waste that could poison water for decades. In situ leaching is far gentler. No open pits, no mountains of tailings, minimal surface disturbance. The land can be restored quickly, sometimes even used for grazing while mining happens below. By keeping uranium-bearing rock underground, ISL reduces the risk of radioactive dust and contamination. It's safer for workers and nearby communities. This is a fundamental shift. Instead of conquering nature, we're learning to work with it. Science and careful engineering allow us to extract resources while leaving ecosystems intact. ISL is mining that seeks to heal, not harm. It's a new way forward, one that respects both our need for energy and the planet we call home. The scars of the past don't have to be the future. This leap in mining is a cornerstone of China's energy strategy. With over 1 billion people, China's electricity needs are enormous. For decades, coal powered the nation, but at a huge environmental cost. Now, China is racing to build a cleaner future with nuclear power as a key pillar. Nuclear plants provide constant, reliable electricity, essential for a stable grid. To fuel these reactors, China needs a secure uranium supply. By developing domestic sources with ISL, China gains energy independence and security. The success of ISL in Inner Mongolia is more than an environmental win, it's a geopolitical game-changer. This silent revolution under the Gobi Desert is powering China's transformation into a clean energy superpower. China's success with in-situ leaching is sending ripples across the global uranium market. Once a major importer, China is now boosting domestic production, reshaping supply and demand. This could lower global prices and spur innovation as other countries take notice. Nations with similar geology are watching closely, seeing new potential in previously uneconomical deposits. China is becoming a world leader in ISL expertise, exporting knowledge and partnering with other nations. This could democratize access to nuclear fuel and break the old uranium cartel. The quiet revolution in Inner Mongolia is creating a new paradigm for resource extraction. Economic development and environmental protection no longer have to be in conflict. By sharing this technology, China could help make clean, reliable nuclear energy more accessible worldwide. The world's energy map is changing, quietly but profoundly. No technology is without risks, and ISL's biggest concern is groundwater contamination. The key to safety is geology. ISL is only used where uranium-rich sandstone is sealed between impermeable layers. Before mining, extensive studies map the underground structure. Monitoring wells surround the site, constantly testing water quality. Operators control the flow, ensuring the solution moves inward, not outward. After mining, companies must restore groundwater to its original quality through careful remediation. This commitment to planning, monitoring and restoration makes safe mining possible. The process is designed to protect water, land and future generations. Responsible ISL is about more than extraction, it's about stewardship. With vigilance and science, the promise of safe mining can be kept. Beyond environmental benefits, ISL makes powerful economic sense. Traditional mining is expensive, giant machines, huge energy use, and only profitable with high-grade ore. ISL flips the model: lower investment, less energy, and profitable even with low-grade deposits. It unlocks resources once considered worthless and can be up and running in just a few years. Producers can quickly respond to market demand by drilling more wells. This flexibility is a huge asset in the volatile energy market. ISL isn't a silver bullet, it only works in specific geological conditions. But where it fits, like Inner Mongolia, it's a strategic economic advantage. Cheaper, faster and more adaptable, ISL strengthens the foundation for a clean energy future. The economics of mining are being rewritten, quietly but decisively. The silent revolution is as much about prosperity as it is about preservation. Can we mine without a scar? In situ. Leaching in Inner Mongolia brings us closer to yes. This is more than technology, it's a change in mindset. Human ingenuity can meet our needs in harmony with nature. We don't have to choose between progress and preservation. This quiet revolution fuels clean nuclear energy while respecting the Earth. It's a step toward a circular economy, taking only what we need and leaving the environment intact. The challenge now is to apply these principles more widely. As citizens, we can support sustainable technologies and demand responsible energy. The future is something we build together. The silent revolution under the desert sands shows what's possible. Now it's up to us to continue the journey.